December 2018. A warehouse in New Jersey catches fire. Firefighters arrive expecting a routine blaze. But when water hits the flames, something terrifying happens. The fire intensifies. Explosions ripple through the building. What they didn't know: thousands of lithium-ion batteries were stored inside, and lithium fires don't care about water. Americans throw away over 3 billion batteries every single year. AA batteries, phone batteries, laptop batteries, car batteries. Most people toss them in the trash without a second thought. But here's the problem. One single AA battery contains enough toxic material to contaminate 600,000 liters of water. And a lithium-ion battery from your laptop? That's a bomb waiting to go off. Today, we're going inside America's battery recycling facilities, where some of the most dangerous and valuable waste on the planet gets transformed back into raw materials for new batteries. This is the hidden industry, keeping our electronic world from becoming a toxic nightmare. Let's start with the scale of the problem. The average American household has over 50 batteries at any given time. Remote controls, flashlights, smoke detectors, toys, phones, laptops, tablets, power tools, electric toothbrushes. We're drowning in batteries. And here's the crazy part. Until recently, most of these just went straight to landfills. For decades, the standard procedure was simple. Throw batteries in the trash, bury them in a landfill, hope for the best. Zinc, manganese, lithium, cobalt, nickel, lead. All of it leaching into groundwater. That started changing in the 1990s when California became the first state to ban battery disposal in regular trash. Other states followed slowly, but enforcement was practically non-existent. Even today, less than 5% of household batteries get recycled nationwide. Then came the electric vehicle revolution. Suddenly, we weren't just dealing with AA batteries anymore. Tesla Model S battery packs weigh 1,200 pounds and contain massive amounts of lithium, cobalt, and nickel. Materials worth thousands of dollars per pack. Materials that are becoming increasingly scarce globally. This caught the attention of J.B. Straubel, Tesla's co-founder and former chief technology officer. In 2017, he left Tesla and started Redwood Materials with a single mission: build America's battery recycling industry from scratch. But before we get to the cutting edge, let's follow a typical battery's journey through the recycling system. It starts with collection. Unlike aluminum cans or glass bottles, you can't just throw batteries in your curbside recycling bin. They require special handling. Retailers like Home Depot, Best Buy, and Lowe's have collection bins near their entrances. Call to Recycle, a non-profit organization, operates over 25,000 collection sites across the United States and Canada. Municipal hazardous waste facilities accept them. Some areas even have special battery collection events. From these collection points, batteries travel to sorting facilities where workers face an immediate challenge: identifying what type of battery they're dealing with. This isn't trivial. Different battery chemistries require completely different recycling processes. Let's start with the most common type: alkaline batteries. These are your standard AA, AAA, C, and D batteries. Inside, they contain zinc, manganese dioxide, and potassium hydroxide. Americans throw away 2 to 3 billion of these every single year. At a facility like Retrieve Technologies in Ohio, one of North America's largest battery recyclers, alkaline batteries arrive in massive Gaylord boxes, each holding thousands of pounds. Workers wearing protective gear sort them manually, removing any lithium or rechargeable batteries that got mixed in. One lithium battery in an alkaline processing line can cause catastrophic fires. The sorted alkaline batteries move to industrial hammer mills that pulverize them into pieces smaller than a 1/4 inch inside sealed chambers. Magnetic separation pulls out steel casings for steel mills. The remaining black powder containing zinc and manganese gets processed through chemical baths that separate and purify each element. The zinc gets refined to 99.9% purity and sold to galvanizing companies that use it to rust-proof steel. The manganese oxide goes to fertilizer manufacturers or gets used in new battery production. Even the plastic labels and paper sleeves get recovered and sent to paper mills. But alkaline batteries are the easy ones. Now let's talk about lithium-ion batteries. These are exponentially more dangerous, more valuable, and more complex to recycle. Here's what makes lithium-ion batteries terrifying. They store massive amounts of energy in a very small space. That's great for your phone. That's terrible for recycling. A damaged lithium-ion battery can enter thermal runaway, a chain reaction where the battery heats itself to over 1,800 degrees Fahrenheit, releases toxic fumes, and can reignite multiple times even after the fire appears extinguished. And here's something most people don't know. Lithium fires can burn underwater. Adding water to a lithium fire can actually make it worse by producing hydrogen gas. Firefighters dealing with electric vehicle fires have to let them burn out or use specialized suppression systems. This is why lithium-ion battery recycling requires completely different facilities. Li-Cycle, a company with plants in New York and Arizona, represents the cutting edge of lithium-ion recycling technology. When lithium-ion batteries arrive at Li-Cycle's facility, they come in special fireproof containers. Workers first discharge any remaining energy using controlled short-circuit systems in explosion-proof rooms. A fully charged phone battery still contains enough power to cause serious problems. Next comes the most critical step: shredding in an inert atmosphere. The batteries enter a sealed chamber flooded with argon gas, which prevents oxygen from reaching the shredding process. Without oxygen, fires can't start. Inside this chamber, industrial shredders tear the batteries apart. What emerges is called black mass. This fine black powder is the holy grail of battery recycling. It contains lithium, cobalt, nickel, manganese, and graphite all mixed together. These materials are worth thousands of dollars per ton, but separating them requires sophisticated chemistry. Li-Cycle uses a hydrometallurgical process, essentially precision chemical extraction. The black mass dissolves in specific acid solutions at controlled temperatures. Each metal precipitates out at different pH levels and temperatures, allowing sequential separation with over 95% purity. The recovered lithium carbonate, cobalt sulfate, and nickel sulfate go directly to battery manufacturers. These materials are chemically identical to freshly mined materials, but require 80% less energy to produce. And here's the kicker. The United States imports over 80% of its lithium and nearly 100% of its cobalt. Recycling makes America less dependent on foreign mineral supplies. But there's one battery type with an even better recycling story: lead-acid batteries. These are the batteries in cars, trucks, and backup power systems. And they're the recycling success story nobody talks about. Over 99% of lead-acid batteries in the United States get recycled. That's a higher recycling rate than aluminum cans or cardboard. Why? Economics. Lead is expensive, and a single car battery contains about 21 pounds of lead, worth $30 to $50 at scrap prices. When you buy a new car battery, retailers charge a core charge, typically $10 to $20, which you get back when you return your old battery. This economic incentive ensures almost every lead-acid battery makes it back to a recycling facility. At facilities like Aqua Metals in Nevada, recycling uses electricity and chemistry instead of furnaces, eliminating toxic lead emissions. Batteries get drained, broken apart, and the lead plates go into electrochemical cells, where electrical current causes pure lead to plate out. Plastic cases get recycled. Even the acid converts into sodium sulfate used in laundry detergent. Now let's talk about the economic reality driving all of this. Battery recycling isn't just about being environmentally responsible, it's about capturing incredibly valuable materials. A single electric vehicle battery pack contains about 15 pounds of lithium, 20 pounds of cobalt, and over 100 pounds of nickel. At current market prices, that's roughly $3,000 to $5,000 worth of raw materials. Multiply that by millions of electric vehicles hitting the road over the next decade, and you're looking at a multi-billion-dollar industry. Redwood Materials, J.B. Straubel's company, already processes battery materials from Panasonic, Amazon, and Toyota. Their Nevada facility can recycle enough batteries to recover materials for 600,000 electric vehicle battery packs per year by 2025. They're not just recycling. They're building a closed-loop supply chain where old batteries become new batteries. Tesla has its own recycling program at their Nevada Gigafactory. They claim to recover 92% of battery materials, including the critical cathode elements. Manufacturing scrap, defective cells, and end-of-life packs all feed back into new battery production. The environmental impact extends beyond preventing toxic waste. Mining lithium requires pumping massive groundwater in Chile's Atacama Desert, devastating local water supplies. Cobalt mining in the Democratic Republic of Congo has serious human rights concerns. Recycling 1 ton of lithium-ion batteries recovers enough material for 50 new battery packs, while eliminating the need to mine 500 tons of ore. But here's where it gets complicated. Current lithium-ion batteries use cathode chemistries that will likely change dramatically over the next decade. Solid-state batteries, lithium iron phosphate batteries, sodium-ion batteries. Each chemistry requires different recycling approaches. Innovation continues accelerating. Some companies are developing direct cathode recycling, where the valuable cathode materials get recovered without breaking them down chemically. This could cut processing costs by 50%. Others are working on battery designs specifically engineered for easy disassembly and recycling. Modular construction, standardized connections, no adhesives, making recycling easier from the moment the battery is designed. Federal regulations are tightening too. The EPA is developing new rules for battery collection and recycling. Several states now require battery manufacturers to fund collection and recycling programs. California's proposed regulations would make producers responsible for recycling their own products. The goal is ambitious: create a circular battery economy where materials flow from old batteries to new ones indefinitely. Where mining becomes the exception, not the rule. Where America builds a strategic reserve of critical materials, not in underground vaults, but in recycling facilities, processing yesterday's electronics into tomorrow's clean energy infrastructure. From your TV remote to electric buses, from power tools to grid storage systems, batteries are everywhere and growing exponentially. The International Energy Agency projects will need 40 times more lithium by 2040 to meet electric vehicle demand alone. We can't mine our way out of this, but we can recycle our way forward. So next time you're about to throw away those dead AA batteries or that old phone, remember, those aren't just trash. They're valuable materials that belong in the recycling system. That alkaline battery in your hand contains enough zinc to rust-proof a square foot of steel. That dead laptop battery contains enough lithium to help power someone's electric vehicle. From toxic waste to tomorrow's batteries. Thanks for watching. Hit that like button and subscribe for more incredible stories about the industries transforming our waste into resources. See you next time.